This tutorial is about the metric system, which I hope to convince you is easier than the imperial system. All students in the U.S. know the imperial system because it's what we grew up with. It's a relic of our time when we were a British colony 243 years ago. Besides us, the only countries that continue to use the imperial system are Myanmar and Liberia. The imperial system, which the UK no longer uses, has about 30 different units of measure that are numerically unrelated to each other. For example, there are 12 inches to a foot, but there are 3 feet in a yard, and there are 1,760 yards in a mile. There are no base units, and conversions between all these different measurements can be very cumbersome. Let's say, for example, that I have a field that is 1/2 mile in perimeter. I need to know how much fencing to buy. Well, first I need to remember that there are 1,760 yards in a mile times 3 gets me to 5,280 feet in a mile, and I have 1/2 mile, so I need to divide that by 2 to arrive at the number 2,640 feet of fencing that I need to purchase. But I had to remember these different numbers to make this calculation. Let's compare the imperial system to the metric system, which is used by the rest of the world. In the metric system, it follows the base 10 numbering, which uses the pattern 1, 10, 100, 1,000. You only need to learn one set of numbers, and conversions are very straightforward in this system. For example, there are 1,000 millimeters in 1 meter. There are also 1,000 meters in 1 kilometer. If we switch to grams, the units don't change, or the numbers don't change. 1,000 milligrams in 1 gram, and 1,000 grams in 1 kilogram. Let's do the fence calculation again with the metric system. In this case, I'll say that my field is about 0.8 kilometers in perimeter. So how many meters of fencing do I need to buy? Well, 0.8 kilometers times 1,000 is 800 meters. So I need 800 meters. It's much easier than dealing with feet, yards, and miles. The metric system is very universal because it has base units. In biology, those common base units for weight are gram, or G, abbreviation. Volume is liter, L, and distance, we use the meter. The position of the base units, gram, liter, and meter, is just to the left of the decimal point on the base 10 numbering system. So recall that in the base 10 system, 10 to the 0 is equal to 1. If you had 5 times 10 to the 0, that would simply be written as 5. Prefixes are added to the base unit name when you want to refer to numbers of a different scale. For example, the prefixes for numbers greater than 10 include kilo, 10 to the 3, mega, 10 to the 6 or million, giga, 10 to the 9, and tera, 10 to the 12. This is only a partial list, I want to remind you. For units that are smaller, we use a different set of prefixes, and those include milli for 10 to the minus 3, micro, 10 to the minus 6, nano, and pico. These units make it easier to refer to either very large or very small numbers. For example, if you had 5,200,000 grams, you could simply refer to this as 5.2 megagrams. The number 0.000038 would be referred to as 3.8 micrograms, much easier to say. Remember that the same prefixes apply to each of the base units. Again, so you only have to learn this one set. You can have kilogram and you can have kilometer or kilometer. This cube represents 1 gram. We're going to divide this cube into 1,000 equal parts. So it's going to be 10 divisions here, 10 here, and 10 in this direction. Now we've got 1,000 small cubes within our large cube, and we're going to look at just one little portion of that. If we take this small cube out of our 1 gram, it's 1 part out of 1,000 divisions that we made. We've now got 1 milligram, or 0.001 gram, but it's easier to say 1 milligram. If we do exactly the same thing in the milligram unit that we have, and we divide that into 1,000 parts, now we've got a very tiny unit here, 1 microgram, which is 1/1000th of a milligram, or 10 to the minus 6 grams. The same pattern holds if I use a different base. In this case, I'm using a liter. Our box is 1 liter. If I divide this into 1,000 pieces and take one of those, I've got a milliliter. And if I further divide that milliliter into 1,000 parts, I've got a microliter. Let's return to the metric line and think of some mnemonics, things that make it easier for us to remember. So we've got our base, GLM. To the left, we've got KMGT. And that's not so easy. You could think of something for that. And on the right, we have MMNP. That's a little easier to remember. I think it's easy to think of anything to the left, of course, means that those are larger numbers. And to the right, we're going to have reduced numbers, smaller. And you might want to draw your metric line like this. Again, here's our base. And here's kilo, here's milli. And notice that there are 2 numbers between each of those positions. That helps you remember what the spacing is. A good way to perfect your understanding of the metric system is to practice conversions. In this case, let's look at a question: how many milligrams are in 5 grams? So we have 5 in this position, and we'll change our base to gram. And this may seem counterintuitive, but as you move to the right, we're going to multiply, because we're going from the left of the decimal point to the right of the decimal point. So we're going to multiply once, twice, and a third time to get us in position for milligrams over here. And that gets us to the number 5,000 milligrams. To help you think about this, let's ask the question: what happened to the number when you changed the units from gram to milligram? As we went from gram to milligram, the number went from 5 to 5,000. So an easy way to remember this and think about it is that if the unit is changing to a smaller unit, then the number must get larger to the same degree. Here's an alternative approach to the same problem. We know that 1 gram equals 1,000 milligrams, and we can write that as a fraction, 1,000 milligrams over 1 gram, because that's equal to 1. These terms are synonymous. Now, given that, we can actually set up a ratio. If we've got 1,000 milligrams over 1 gram, that will equal some number x, which is what we're looking for, over 5 grams. Now we can solve for x by multiplying both sides by 5 grams. It cancels on the right, grams cancel on the left, and we're left with x is equal to 5 times 1,000 milligrams. I've already canceled those. And we get our answer, which is the same answer that we had arrived at previously, 5,000 milligrams. Here it is visually, going back to our 1 gram cube, which contained 1,000 milligram cubes. And if we have 5 of those, clearly we have 5,000 milligrams. Well, let's ask a different question. How many kilograms are in 5 grams? Well, earlier we said if you move right, you multiply. Now, if you're going to move left, you're going to divide. So we're going to divide by 10, once, twice, 3 times to get our answer, which in this case is 0.005. And notice we've got our kilo position here, 2 other zeros in between, and there's the original 5 that we had. What happened to the number when you changed units from gram to kilogram? As we went from gram to kilogram, we divided, and the number went from 5 to 0.005. So what we see is that if the unit is changing to a larger unit, gram to kilogram, for example, then the number must get smaller, again to the same extent. We're changing 1,000-fold from gram to kilogram, and our number decreases 1,000-fold. As you become more familiar with the metric system, you can simply work with the numbers. Since 1 kilogram is equal to 1,000, we can make this fraction 1 kilogram over 1,000 grams because that's equal to 1. And given that, we can use that to solve for x, since x kilograms over 5 grams will equal this. If we multiply both sides by 5, we can simplify on the right, and we're left with x is equal to 1 kilogram over 1,000 grams times 5. So we can get rid of the grams, and we're going to divide 5 by 1,000 to get to our answer, which is the same that we arrived at previously, 0.005 kilograms. Thank you for listening.